Hello friends, in today's session we are going to see some new topics related to our chapter, that is collection framework. Okay, so we were looking about the list iterator interface and the methods defined by list iterator interface. Those were like void add e object, insert object into the list in front of the element that will be returned by the next call to next. Boolean has next returns true if there is a next element, otherwise it will return false. Has next will always return true if there is an element present. Then Boolean has previous returns true if there is a previous element, otherwise it returns false. E next returns the next element. A no such element exception is thrown if there is not a next element. Okay. Then integer next index returns the index of the next element. If there is a not next element, returns the size of the list. Okay, total size of the list. Then previous returns the previous element. A no such element is present. If no such element exception is thrown if there is not a previous element present. Integer previous index returns the index of the previous element. If there is not a previous element, returns -1. Void remove the current element. Wherever your current index or current pointer is. An illegal state exception is thrown if remove is called before next or previous is invoked. Okay. Before your next method call or previous method call, if you are invoking the remove, then it will throw the illegal state exception. Void state e object assigns object to the current element. This is the element last returned by a call to either next or previous. For collections that implement list, you can also obtain an iterator by calling list iterator. Okay. So whatever collection that implement the list interface, you can also obtain the iterator. Okay. So list iterator is common to them. As explained, a list iterator gives you the ability to access the collection forward or backward direction and lets you modify the element. So there are two elements, two advantages to have the list iterator interface. First is you can access the collection element in either forward or backward direction and it let you modify the element. That is the second advantage. Otherwise, list iterator is the same as the iterator interface. The following example we will see. In this, we will implement this step and both iterator and list iterator interfaces are explained. Okay. Array list object is used in this case, but general principles apply to any type of collection. Okay, so it can be array list, it can be linked list, it can be hash set, it can be linked hash set, and so on. Principles will be same for all general collection types. List iterator is available only to those collections that implement the list interface. Now we will see the iterator interfaces in detail. Array list is created of type string A, E, B, D, F. C, A, E, B, D, F are added. Now I will use the iterator. Original contents are iterator using the iterator interface. Iterator object is created al.iterator. While iterator has next, string element iterator dot next and element is displayed. Then next is new line. List iterator object is also created. While list iterator has next, list iterator dot set element plus. Okay. So here you can modify the element. Here you are printing the element plus space, only printing, and list iterator object dot set that particular element plus. Okay, so modified contents of array list are al dot iterator is equal to al dot iterator. Okay, then next, while iterator has next, again we are using the iterator object to display the elements and what are those modified elements. Now the list backward direction using the list iterator object dot previous. This will be your element and element is printed over here. Okay. Original contents are displayed C, A, E, B, D, F. and using has next and modified list iterator dot set plus plus. This is the modified content, and in the backward direction we have iterated using the list iterator interface, that is F, D, B, E, A, and C. Okay. How the list is displayed in reverse. Okay. How it is using previous. After the list is modified, list iterator object points to the end of the list. Literator or list iterator has next return false if there is no element or when the end of list is encountered. To traverse in reverse, you use the backward or previous method. The element is obtained and displayed as long as there is an element present. The for each alternative to iterator. Okay. So far we have used iterator plus list iterator. Now we will see the for each alternative to iterator. If you want to be modifying the contents of the collection or obtaining elements in reverse order, then the for each version is always available, more convenient to cycling through the collection that is using iterator. Okay. So if you don't want to iterate through a collection in backward direction, or if you don't want to modify any element in the collection, so simple and efficient approaches for each loop. Recall that the for can cycle through any collection of objects that implement the iterable interface. All of the collection classes implement this interface. They can all be operated upon by the for. Okay. All of the collection implement the iterable interface first of all, and they can be operated upon by for, that is for each alternative. Now we will see the for loop to sum the contents of the collection. Array list of integer object is created 1, 2, and 3, 4, and 5. Original contents of vals, integer v, vals v plus float, integer v colon vals, sum plus is equal to v. So these values are summed up using the for loop. That is the for each type. For each element of type integer, each element v of type integer in collection vals, we are displaying the element plus space, and whatever the output is, it is displayed here. All the elements are displayed in this case, and in this case all the elements are summed up. First of all, elements are displayed 1, 2, 3, 4, and 5, and sum of values 15 is displayed. For loop is substantially shorter and simpler to use than the iterator based approach. Okay, because it is very simple, very much same as the normal for loop. Okay. But you can only use it for the forward direction and you cannot modify the contents. Storing user-defined classes in collection. For the sake of simplicity, the foregoing examples have stored built-in objects such as string and integer in a collection. Okay. Only we are going to see the string and integer examples that are user-defined classes to in the collection. Collection are not limited to the storage of built-in object. Only string, only float, only double is not limited to. Quite the contrary. The power of collections is that they can store any type of object, including object of classes that you create. Like in array list, you can create the array list of the class that is declared in your project. This is the very simple example. Okay. But for the sake of simplicity, what we are going to do is we are going to only store the string and integer objects. Consider the following example that uses linked list to store mailing addresses. String name, street, city, state, and code, all of string elements. This parameterized constructor is used to store or initialize the elements. Then public string to string, street, city, state, and code. Okay, linked list ml is equal to new linked list, that is the mailing address. Now mailing address dot add new address. All elements will be added: name, street, city, state, country, code. Okay. So now, this is the toString overridden, and mailing address are added one by one like a single object. Okay. So what is the important thing to notice over here? This is the important thing. Address. Address is not a built-in type. It is not a string, it is not a float, it is not a char, and so on. This is the class that you have created over here. This is the class. Okay. So in collection, you can store any type of object, including the classes that you create. This is the proof of that. Okay. So now output is displayed for each element, for each address element in address. We are displaying from the mailing list. We are displaying all the elements one by one. Another important thing, aside from storing a user defined class, it is a quite short. Why short? Because in very simple and very few lines of code, we have added so many addresses into our project. When you consider that it sets up a linked list that can store, retrieve, and process mailing addresses in about 50 lines of code, the power of collection framework begins to become apparent. So actual value of or actual usage of your collection interfaces or collection framework is introduced over here in this program. It is seeming to be very simple program, and in very few lines of code we have added mailing addresses, okay, to the linked list one by one, and it is very easy to understand also, it is easy to remember also and learn also. Or if all of this functionality had to be coded manually, the program would be several times longer. Okay. So we all are programmers. We know very much well about C programming, C++ programming, and whatever was there before the collection was introduced. If there was no collections available, we had to code the program very much longer than this program. Okay. As simple as that. Collections offer off-the-shelf solutions to a wide variety of programming problems. Okay. So very big problems and very simple solutions are available. You should use them whenever the situation presents itself. So you should smartly use the collection in your program. The random access interface. The random access interface contains no members. By implementing this interface, the collection signals that it supports efficient random access to its elements. Okay. So whenever you are using the interface, that is random access interface, the collection is telling you that this support efficient random access, randomly accessing to its element. Okay, although collection might support random access, it might not do so efficiently. Okay, it is seeming to be simple, but it is not actually efficient. The random access interface client code can determine at runtime whether the collection is suitable for certain type of random access, especially as they apply to a large collection. Okay. If you are using the random access interface, the client code will check first at runtime that for this collection is suitable for certain type of random access or not. Okay. It will check at runtime. You can use instance of to determine if a class implement an interface. Okay. If the class is an instance of the random access, then it is actually implementing the random access interface. Okay. Now, random access is implemented by ArrayList and by legacy vector class, among others. Working with maps. Now we will see maps. Okay. A map is an object that stores association between key and value pair. Key, you are giving a key, you can find its value. Okay, it is like a lock and its key. If particular key is used to open a particular lock, not every key is available for every lock. Every lock is different, every key is different. Like every key is different here and every value is different. Both keys and values are objects. The key must be unique, but the values may be duplicated. Okay. Some maps can accept a null key and null values, other cannot. Okay. So what you have to do, remember this, you have to practice. There is one key point about map is that it is important to mention at the outset, they don't implement the iterable interface. So you cannot iterate through a map. Like we have seen in the collection. In the collection, we were all the collection was implementing the iterable interface, but here in this case map don't implement the iterable interface. You cannot cycle through a map using for each style for loop. You can't obtain an iterator to a map. You can obtain a collection view of map which does allow to use either a for loop or an iterator. Okay, so what you will do, you will cover, if you want to iterate through a map, what you will do, you will find out the collection view of a map. So simply you will convert that map to a collection and then you can iterate through a map. Map interfaces. The map interfaces define the character and nature of maps. This discussion of maps begin with them. Okay. So first of all, like in the previous version, what we saw, we first introduced about collection interfaces and then we moved to the collection classes. So whenever a class is implementing the collection interface, you should know about which interface is made for what purpose, and after all, next thing is which interface is having which methods in that, so that whenever a class is implementing that interface, which methods that class must implement. Okay, so same way here also, what you have to understand first the interfaces, map interfaces, then we will move to the map classes. The following interfaces support maps. First is map. Maps unique key to values. Map.entry describes an element, a key value pair in a map. This is an inner class of a map. Navigable map extends sorted map to handle the retrieval of entry based on the closest map searches. Okay, navigable map extend the sorted map to handle the retrieval of entries based on closest match searches. Sorted map extend maps so that the keys are maintained in ascending order. Each interface is examined next. First is map interface. So how many interfaces are there? First is map, second is map.entry interface, third is navigable map interface, and fourth is sorted map. So we will see one by one all interfaces. First interface is map interface. The map interface maps unique key to values. A key is an object that you use to retrieve the value at a later date. Given a key and value, you can store the value in a map object. After the value is stored, you can retrieve it by using its key. Map is generic and declared as interface map K and V, where K is the key and V is the value. Here K specifies the type of key and V specifies the type of value. The methods declared by map are seen in next table 1710. The several methods throw a class cast exception when an object is incompatible with the elements in a map. So whatever when you are storing into the map and it is not compatible with the element that needs to be stored, it will throw the class cast exception like we have seen in the collection version. The null pointer exception is thrown if an attempt is made to use a null object and null is not allowed. An unsupported operation exception is thrown when an attempt is made to change an unmodifiable map. An illegal argument exception is thrown if an invalid argument is used. Maps resolve around two basic operations, get and put. To put a value into a map, use put specifying the key and the value, and to obtain, use get passing the key as an argument. The value is returned. As mentioned earlier, although part of the collection framework, Maps are not themselves collections because they do not implement the collection interface. Okay. Maps are not collection, but you can obtain the collection view of a map. They are not themselves connection. You have to remember. You can obtain the collection view of a map. To do this, you can use the entry set method. And if you are after you are using the calling the entry set method, you can iterate through a map. It returns the set that contains the elements in the map, and then you can use the for each style for loop or iterator object to iterate through a map. To obtain the collection view of key, use key set. To obtain the collection view of values, use values. Collection views are the means by which maps are integrated into a larger collection framework. Okay. Now, methods defined by map. Void clear removes all key value pair from the invoking map. Boolean contains key object k. Returns true if the invoking maps contains k as a key, otherwise returns false. Boolean contains value object v. Returns true if the map contains v as the value, otherwise it returns false. Set map entry k key value entry set returns set that contains the entries in the map. The set contains object of type map.entry. Thus, this method provides a set view of invoking map. Boolean equals returns true if an object is a map and contains the same entries. Otherwise, it returns false. We get object k returns the value associated with the k key, returns null if the key is not found. Integer hash code returns the hash code for the invoking map. Is empty returns true if the invoking map is empty, otherwise it returns false. Set k key set returns a set that contains the key in the invoking map. This method provides a set view of the keys in the invoking map. We put k v puts an entry in the invoking map, overwriting any previous value associated with the key. The key and value are k and v respectively. Returns null if the key did not already exist. Otherwise, the previous value linked to the key is returned. Void put all map extends k extends v m puts all the entries from m to this map. Then we remove object k removes the entry whose key values are key equals k. Integer size returns the number of key value pairs in the map. Collection v values returns a collection containing the values in the map. This method provides a collection view of the values in the map. Then next is sorted map interface. The sorted map interface extends map. It ensures that the entries are maintained in ascending order based on the keys. Sorted map is a generic and is declared as shown here. Interface, sorted map, key and v. Okay. So sorted map, as the name suggests, first of all it's extend map, and second is entries are maintained in sorted, that is ascending order based on the key, not on the value. Where k specifies the type of key and v specifies the type of value. Methods declared by sorted map are summarized in the table 1711. Several methods throw no such element exception when no items are in invoking map. No such element is present, like no key and no value. A class cast exception is thrown when an object is incompatible with the elements in the map. A null pointer exception is thrown if an attempt is made to use a null object when null is not allowed in the map. An illegal argument exception is thrown if an invalid argument is used. Okay. Sorted maps allow very efficient manipulation of submap, in other words, subset of a map. So when you are creating subset of a particular map, you can very efficiently manipulate it if you are using the sorted type of map. To obtain a submap of a map, what you will use? Head map, tail map, or submap. To get the first key, call first key. To get the last, using last key. The methods of sorted map are shown here. Comparator, super k comparator returns the invoking sorted maps comparator. If a natural ordering is used for the invoking map, null is written. K first key returns the first key in the invoking map. Sorted map key value head map key end returns a sorted map for those map entries with keys that are less than end. K last key returns the last key in the invoking map. Sorted map KV submap K start K and returns a map containing those entries with keys that are greater than or equal to start and less than the end. Okay. So sorted map submap returns a map containing those entries that are greater than or equal to start. Okay. And less than end. So between start and end, it will give you submap. Tell map K start from start returns a map containing those entries which with the keys that are greater than or equal to start. The navigable map interface. The navigable map interface was added by Java 6. It extends sorted map and declares the behavior of map that supports the retrieval of entries based on the closest match to a given key or keys. Okay. So what it does, first of all, it extends the sorted map interface. Navigable map interface extends sorted map and it declares the behavior of map like that. It supports the retrieval of entries based on the closest match to a given key or keys. Navigable map is a generic interface like interface navigable map K and B. Here K specifies the type of key, B specifies their values. So in addition to the methods from sorted map, some are added in the following table. Several methods throw class ka step exception like in the previous examples when an object is incompatible with the keys in the map. Then null pointer exception is thrown if an attempt is made to use a null object and null keys are not allowed. An illegal argument exception is thrown if an invalid argument is used. So what are the methods defined by navigable map? Map.entry KV. Sealing entry K object searches the map for the smallest key K such that K is greater than equal to object. If such a key is found, its entry is returned, otherwise null is returned. Okay. So smallest key K has to be found, like K should be greater than or equal to the object. If found, it will return, otherwise null is returned. Key sealing key searches the map for the smallest key such that K is greater than is equal to object. If a such key found, the key is only returned. In the previous sealing entry, it will return both key and value, and here sealing key only key is written, otherwise null is returned. Navigable set K descending key set returns the navigable set that contains the key in invoking map in reverse order. Thus, it returns a reverse set view of the keys. The resulting set is backed by the map. Navigable map KV descending map returns a navigable map that is reverse of the invoking map. Resulting map is backed by the invoking map. Map.entry KV first entry returns the first entry in the map. This is the entry with the least key. Floor entry searches the map for the largest key K such that K is less than is equal to object. If the such key is found, its entry is written, otherwise null is returned. Floor key, only key is written in this case whose value is less than is equal to object. Okay. Navigable map KV head map K upper bound boolean inclusive returns a navigable map that includes all entries from the invoking map that have keys that are less than upper bound. Okay. So upper is the greatest value and whatever values you will be fetching, those will be lesser than the upper bound. If inclusive is true, then the element is equal to upper bound is included. The resulting map is backed by the invoking map. Map.entry KV higher entry K object searches the set for the largest key K such that K is greater than object. If such key found, its entry is returned, otherwise null is returned. K higher key K object searches the set for the largest key K such that K is greater than is equal to greater than object. If such key is found, it is returned, otherwise null is returned. Map.entry KV last entry returns the last entry in the map. This is the entry with the largest key. Map.entry KV lower entry K object searches the set for the largest key K such that K is less than object. If such a key is found, its entry is returned, otherwise null is returned. K lower key K object searches the set for the largest key K such that K less than object. If such key is found, it is returned, otherwise null is returned. Navigable set K, navigable key set, returns a navigable set that contains the key in invoking map. The resulting set is backed by the invoking map. Map.entry KV poll first entry returns the first entry, removing the entry in the process. Because the map is sorted, this is the entry with the least key value. Null is returned if the map is empty. Then map.entry KV poll last entry return the last entry, removing the entry in the process. Because the map is sorted, this is the entry with the greatest key value. Null is returned if the map is empty. Navigable map KV submap K lower bound boolean low inclusive, K upper bound boolean high inclusive returns a navigable map that includes all the entries from the invoking map that have keys. Those are greater than lower bound and less than upper bound. So in between submap is pasted over here. If low inclusive is true, lower value is included, then an element equal to lower bound included. If high inclusive is true, then an element equal to high inclusive is included. The resulting map is backed or written by the invoking map. Navigable map KV tail map K lower bound boolean inclusive returns a navigable map that includes all entries from the invoking map that have keys that are greater than lower bound. If inclusive is true, then an element equal to lower bound is included. Resulting map is backed by the invoking map. Next is map.entry interface. Map.entry interface enables you to work with a map entry. Recall that the entry set method declared by map interface returns a set containing the map entries to iterate through a map. Each of these set elements is map.entry object. Map.entry is a generic and it is syntax is interface map.entry K, V. Here K specifies the type of key and V specifies the type of values. Table next 1713 summarizes the methods. Various exceptions are possible, like we have already introduced, like null pointer exception, illegal argument exception, incompatible type exception, and so on. Those are same for all the maps. Boolean equals object obj returns true if obj is a map.entry whose key and value are greater than are equal to that of invoking object. Key get key returns the key for this map entry. V get value returns the value for this map entry. Integer hash code returns the hash code for this map entry. V set value VV sets the value for this map entry to V. A class cast exception is thrown if V is not the correct type of the map. An illegal argument exception is thrown if there is a problem with V. A null pointer exception is thrown if V is null and map does not permit null keys. An unsupported operation exception is thrown if the map cannot be changed. Then map classes. Several classes provide implementation of map interfaces. Now we will see those classes. Weak hash map extends abstract map to use hash table with weak keys. Linked hash map extends hash map to allow insertion order iteration. Identity hash map extends abstract map and uses reference equality when comparing documents. Abstract map is a superclass for all concrete map implementation. Weak hash map implement a map that uses weak keys, which allows element in a map to be garbage collected and when key is otherwise unused. Okay. So first is weak hash map. It extends abstract map to use hash table with weak keys. So there are weak keys available. Linked hash map extend hash map to allow insertion order iteration. And identity hash map extend abstract map and uses reference equality when comparing documents. So we will see them one by one. Weak hash map implement a map that uses weak keys which allows an element in a map to be garbage collected. This class is not discussed, that is weak hash map is not discussed over here, and other are we will see next in the next sessions. Okay, so in this way we have come up to the map classes. Okay, so in the upcoming session we will try to complete all the remaining topic related to collection framework. Okay, so these all are very interesting topics and it is not like a by-hearting of all the methods and all their syntaxes. The actual enjoyment of Java is when you are actually implementing your own code and by your own without getting anybody's help. So that is the important thing. Okay, just create any random program that you want in your own Eclipse version, create your own question and try to practice and try to include all the functions that I have explained you in this session or in all the previous sessions. Try to use each and every function in your program or in your project and try to understand how it is actually working. Okay, so main thing is that when I am explaining you anything and you are trying to by hearting or learning or remembering it, it is another way of learning. And when you are actually want to learn it, then what you will do, you will actually implement it in your code and then you will understand it better. Okay, so try to practice all these functions at home and enjoy Java programming. Java is not like by hearting thing. It is actually a learning thing, and learning is enjoyable process. It is not like I am telling you, I am teaching you, and you are sleeping over there. It is not like that. If you are doing it by your own, you are taking interest by your own, you can enjoy it. Okay, and everybody can enjoy Java. Everybody can learn and love programming. Okay, so try to love programming, not try to by heart your functions, syntaxes, and remember and remember and remember. Okay, so I hope you are understanding what I am talking about. Meet you in the next session with some more interesting topics. So thank you so much.